calculus students. So today I'm going to go through the chapter 1, part 2 test review. I'm going to do each problem in this video, but you can skip ahead to whatever problem you're looking for, whatever problem that you need help with. Let's go ahead and start with the first ones. Questions 1 through 2 state for each of the following, we're finding f minus g of x, f g of x. This means to multiply f and g together. C is f divided by g of x. And D is f plus g, and then negative 3 is off by itself. On question 1, we're given two functions, f of x equals 2x plus 3, and g of x equals x minus 1. So for part A, my question states to take f minus g, and I'm just going to subtract those two values. F is 2x plus 3 minus g is x minus 1. Now we're going to simplify that by distributing the negative through those parentheses to get rid of the parentheses. Negative times x is negative x, and a negative times a negative 1 is positive 1. Now I'm going to combine like terms together. 2x minus x is 1x, and 3 plus 1 is 4. So on part A, that simplifies to x plus 4. On part B, we're taking our two functions and multiplying them together. 2x plus 3 times x minus 1. These are two binomials, so I'm going to FOIL these together to multiply them. 2x times x is 2x squared. That's the f. 2x times negative 1 is negative 2x. It's the O. The inner terms is 3 times x, which is 3x. And last is 3 times negative 1, which is negative 3. Now that I've FOILed, we're going to combine like terms together to simplify this. 2x squared can stay. Negative 2 plus 3 is positive 1. X and then minus 3 is at the end for the constant. So that's how you do B. FOIL those two binomials together. On question C, it says take f and divide by g. That's all I'm going to do. F is 2x plus 3 divided by g, which is x minus 1. The numerator, we cannot factor it at all because they don't have anything in common. And the denominator, we can't factor either. So we're done. C is just simply dividing the top and the bottom. On question D, we're going to take our function f and function g and add them together. 2x plus 3 plus x minus 1. 2x plus x is 3x, and 3 minus 1 is positive 2. Now on this one, we've got a little bit of extra work to do because instead of just putting an x there, we have a negative 3. What that means is everywhere that we see an x, we're going to substitute in negative 3 for that x. And then simplify that. 3 times negative 3 is negative 9, plus 2 is negative 7. And that's how you do question 1, parts A, B, C, and D. On question 2, we're given two more functions. F of x is x minus 5, and g of x is 3x squared. I'm going to do the same thing we did on the last problem, starting at part A. F minus g is f of x minus the g function. There are no like terms there, and that one's done. Because I can't combine anything, we can just stop there on A. Part B tells us to multiply f times g. F minus 5 times g, which is 3x squared. To multiply, I'm going to distribute 3x squared into both terms in the parentheses. 3x squared times x is 3x cubed, right? There's 3 x's now, so it's x cubed. Negative 5 times 3 is negative 15, x squared. Those are not like terms either, so we're just going to leave it as is. Part C says to take f, which is x minus 5, and divide by g, 3x squared. Those do not have any greatest common factors, so I'm just going to leave it the way it is. Part D says to take f plus g, which is just like this. Take f of x and add it with g of x. There are no like terms, so I'm done with the addition part. Now I'm going to go back, and everywhere I see an x, put in negative 3. So in place of x, I put negative 3. Now I'm going to simplify that. Negative 3 minus 5 is negative 8. Negative 3 squared is 9. 3 times 9 following PEMDAS is 27. So that's how you do question 2. Questions 1 and 2 both came from section 1.8, where we talked about composite functions. So if you struggled with those, I would go back and look at section 1.8 in your notes. On question 3, states for each of the following find A is g of f of x, and B is f of g of 2. These were composite functions as well from section 1.8. Question 3 gives us a function f of x equals 2x, and g of x equals x plus 7. So for part A, g is the outside function. F of x is the inside function. So inside here, I'm going to put 2x. What that means is everywhere I see an x in the g function, I'm going to put the 2x in its place. So this is 2x plus 7. And that's all that evaluates to be. I took f, plugged it into the g function, and I can't simplify. So we're done with that one. On question B, it says to take f of g of 2 and evaluate that function. G of 2, let's go find that first. G of 2 is found by taking 2 and substituting it everywhere I see an x in the g function. So g of 2 is 9. Now that we know what g of 2 is, I'm going to substitute that as 9. Now to find f of 9, take 9 and just plug it into the f function. 2 times 9 is 18. So that's how you do question 3 with composition of functions. Question 4 is very similar to question 3. We're given two functions. F of x is 7x plus 1, and g of x is 2x squared minus 9. For part A, to find g of f of x, I'm going to take f of x, which is the inside function, and put it in place of this part, 7x plus 1. Now we can evaluate. G of 7x plus 1, we can find that by just taking 7x plus 1 and putting it in place of x in the g function. Okay, so that's all I did there. Take 7x plus 1, plug it in place of x in the g function. Now we're going to simplify this. 7x plus 1 squared is 7x plus 1 times 7x plus 1. To multiply those two binomials together, we're going to FOIL through. 7 times 7 is 49, and then x squared because there were two x's. 7 times 1 is positive 7x. 1 times 7x is 7x. And 1 times 1 is 1. I'm going to leave that in parentheses because I'm still simplifying it. Because you have like terms, 7x and 7x makes 14x plus 1. All right, next step is I'm going to distribute that 2 through the parentheses because we're multiplying. 2 times 49 is 98x squared. 2 times 14 is 28x. And 2 times 1 is 2. Now that we've got rid of parentheses, we're just going to combine like terms together. 98x squared does not have any like terms to combine with it. Neither does the 28x. But this 2 minus 9 does. Makes negative 7. So that's your final answer on part A. To evaluate part B, we're taking f of g of 2. First, we need to find g of 2. That's found by taking 2 and plugging it in place of x, just like our function notation tells us to do. Now I'm going to evaluate that. 2 squared is 4. 2 times 4 is 8. Minus 9 is negative 1. G of 2 evaluated to be negative 1. Now we're going to go evaluate f of negative 1. Everywhere you see an x in the f function, put in a negative 1 and just simplify. 7 times negative 1 is negative 7, plus 1 is negative 6. So part B just simplified down to negative 6. Questions 3 and 4 were composite functions. That came from section 1.8. So if you struggled with those, I would go back and look at your notes from section 1.8. Questions 5 through 6 ask us to decompose k of x into two functions so that k of x equals f g of x. This also comes from section 1.8. On question 5, we know that k of x is 5 plus x minus 1 to the third. So this time, I'm asking you to tell me what f of x is and what g of x is, so that when we compose them, we get that k of x function back. There's a lot of ways to do this. The easiest way we talked about in class is the inside function is the same as the inside part of the equation. Whatever's inside the parentheses or the absolute value bars, whatever it may be. So the inside function g of x, I'm going to let be x minus 1. Now that I've used the x minus 1, I'm going to put an x through it. And everything else is the f of x function. 5 plus x to the third. That is how you can decompose that function into f of x and g of x. On question 6, I'll come over and do that one. K of x is the absolute value of x plus 2 minus 1. And you're asked to tell me f of x and g of x. Just like question 5, the inside function is the inside of the bars, which is x plus 2. So I'm going to let g of x be x plus 2. We have used that piece, so I'm going to x it out. And f of x is everything that's remaining. X minus 1. On questions 7 through 12, our question states graph the parent functions. I'm just going to draw a sketch of each of these. Question 7 says f of x equals x to the third. That is the cubic function we learned about in class. And it looks like the S shape going through the center of the graph. Question 8 says f of x equals x squared. That was the quadratic function that looked like a U shape, also going through the center of the graph. Question 9 is f of x equals the cube root of x. This one was the cube root function that looked like a sideways S. On question 10, f of x equals the absolute value of x. That function looks like the letter V. Question 11, f of x equals the square root of x. This one is the arc kind of shape that we talked about in class. It's the square root function. And last one, f of x equals just plain x. That is a linear equation, which makes a line. Those were the 6 parent functions that we learned about in section 1.6a at the beginning of our unit. On questions 13 through 15, our directions state evaluate each function for the indicated values. Be sure to simplify your answers. We know that f of x is x minus 4 divided by the absolute value of x. Evaluate, remember, means to substitute in. That's exactly what I'm going to do. F of 3 means that I'm going to take 3 and substitute it in for x into the function. Don't forget to simplify this. 3 minus 4 is negative 1. The absolute value of 3 is just 3. So 13 simplifies to negative 1/3. On 14, we're evaluating f of negative 11. This time, I'm going to take negative 11 and substitute it in for x. Everywhere you see an x. Negative 11 minus 4 is negative 15. The absolute value of negative 11 is positive 11. So that simplifies to negative 15 over 11. Last one here, f of a. All that means is take a and substitute it in for x. A minus 4 over the absolute value of a. That's a little review for you from section 1.3a, from the first part of chapter 1, where we talked about evaluating functions. On questions 16 through 18, our question states find the inverse of the following equations. On question 16, f of x equals 3x plus 4. Whenever you are finding the inverse, there was a series of steps we wrote down in our notes when we learned this lesson. The first one is to replace the f of x with y. To find the inverse, I'm now going to flip x and y. So we're going to flip where they're at. And then the last step is solve for y. Those are the 3 steps we use to find the inverse of a function. So first step, replace f of x with y. Second step, flip x and y. So now this equation is x equals 3y plus 4. And the third step is solve for y. I'm going to subtract 4 to both sides and divide by 3. So x minus 4 over 3 equals y. Because we're finding an inverse though, I'm going to use that inverse notation we learned about, f inverse of x. That's how you find the inverse of a function. On question 17, we're given the equation g of x equals 2x plus 3 divided by 4. First step is to replace the g of x or the f of x function with y. Second step is to flip x and y. So I'm just going to flip where those are in my equation. And third step is to solve for y. To solve for y, I'm going to first multiply both sides by 4 to get the 4 on the other side. Subtract 3 from the left and right side. And last step, divide by 2. Because I'm multiplying here, I'm dividing everything by 2. Okay, now we got our y by itself. 4x minus 3 over 2 equals g inverse of x. Don't forget your function notation there. And that's the inverse of that function. On question 18, we're given the function h of x equals 2/3 x minus 6. And I'm just going to follow my same steps that I've been doing to find the inverse. First, h of x, we're going to replace that with y. That's step 1. Step 2 is to flip x and y, where they're located at in my equation. And step 3 is to now solve for y. To solve, I'm going to add 6 to both sides. Now, because this is a fraction, I'm going to work it one piece at a time. To get rid of this 3 in the denominator, I can do that by just multiplying both sides by 3. So I'm going to multiply this side by 3 and the left side by 3 and distribute that, which is 3x plus 18. You can distribute that through. On the right side, now I still have 2y. To get rid of the 2, I'm going to divide both sides by 2, which gives us 3x plus 18 over 2 equals the inverse function, h inverse of x. So that's how you find the inverse of any function using these 3 steps. If you struggled with these questions, this comes from section 3.1a, where we talked about finding the inverse of functions. On questions 19 through 20, there are multiple parts to these. First, we're going to find the min or maximum value. We're also going to write the intervals that the function is increasing, decreasing, or constant. And next, we're going to state if the function is even or odd. This part you do get a calculator on. Starting with question 19, we have the function f of x equals x squared plus 6. Once you type that in the calculator, this is what your sketch is going to look like. Now that we know what the sketch looks like, we can go identify all of our parts. On part A, this does have a minimum because it's got a low point in the graph. Now let's go find that minimum value in your calculators. To find the minimum value in your calculator, first we need to type in the function x squared plus 6. And you can graph it to see what that's going to look like. To find the minimum, this low point in the graph, I'm going to go to second, trace, and go down to number 3, where it says minimum. Left bound means I'm going to go somewhere to the left of this minimum value. just anywhere to the left, and click enter. Right bound means I'm going to go somewhere to the right of that minimum value, over here, and click enter. And then guess, I'm going to click enter one more time. Don't move the spider or anything, just click enter. And there's your minimum value. The X has an E here, which means it's really close to 0. So for X, this is at 0, and the Y is at 6. That's your minimum value, 0, 6. Now we're going to talk about where the function is increasing, decreasing, or constant. Remember, this is always based on the X intervals with parentheses. As you can tell from the left side of the graph, it's going down, meaning that it is decreasing. From the left side at negative infinity, because it's the left side of the function. It stops decreasing right here at the X value of 0. I'm going to use parentheses there because increasing, decreasing, constant uses parentheses. After we get to the minimum value, the function begins going up and it increases from 0 off to positive infinity to the right. So that's increasing and decreasing for those intervals. The last part, question C, asks us to determine if the function is even or odd. How to tell if a function is even or odd? We're going to take negative x and plug it in place of the x in our function and simplify. Negative x squared, a negative squared is positive x squared plus 6. This function matches the original, so since no signs changed, this is an even function because no signs changed. You can also tell that by looking at the graph. It is foldable, which also means that it could fold in half on top of itself. That also makes it an even function. On question 20, our function is f of x equals negative x cubed plus 2x. We're doing the same thing we did on question 19 with identifying those 3 parts. First, let's go type this in the calculator so you can get a sketch of what the graph is going to look like. Once you type that in, your graph is going to look something like this. As the low point here comes up, and then goes off like that. That's what it looks like in your calculator. Now that we have a sketch, let's talk about our minimum and maximum values. The low point in this graph is right there, and that is a minimum. We do have a minimum value. We also have a high point in this graph here. That is a maximum. There actually is a min and a maximum value for this graph. Let's go find what that is in our calculators. First, we need to type this function into your calculator, so make sure that you type in that f of x function into your graphing calculator and hit graph. That's what our sketch looks like. To go find this minimum value first, I'm going to go to second, trace, down to minimum. Left bound means I'm going to move this spider somewhere to the left of that low point and click enter. Right bound means that I'm going to move the spider to the right of that minimum value. And click enter. And then guess means I click enter one more time. That's your minimum value. We're going to round to 3 decimal places. So this will be negative 0.816, comma, negative 1.089 for the minimum value. I'm also going to go ahead and get the max by going back to second, trace, down to maximum. Left bound means I'm going to go somewhere to the left of that maximum point. Right bound means I'm going to go somewhere to the right of that maximum point. And click enter one more time. So there's your maximum value, 0.816, comma 1.089. Now let's talk about the intervals that the function is increasing, decreasing, or constant on. From the left side, we can see that the graph is going down, which means it's decreasing. From negative infinity, because it's from the left, stops decreasing at negative 0.816 for the x value. Somewhere else this function is decreasing is over here on the far right side. That's from 0.816 all the way to positive infinity because it goes to the right. Now I'm going to use a U to join those two pieces together. Now the increasing interval. The function is increasing right in this area between negative 0.816 and positive 0.816. That's where the function's increasing. Now let's talk about even and odd. To find if it's even or odd, I'm going to take f of negative x and plug in a negative in place of both of my x's. Negative, and then in place of x, put negative x cubed. And in place of x, we're going to put negative x and simplify this. Negative x cubed, a negative times a negative times a negative is just negative x cubed. 2 times negative x is negative 2x. This double negative does make that a positive x cubed minus 2x. Now, since we've simplified this, as you compare these signs with these signs, you'll notice that the signs changed from negative to positive, positive to negative. Because the signs changed, all the signs changed, this function is odd. Because all the signs changed. That's a little review for you over section 1.7a, where we talked about analyzing graphs. On questions 21 through 23, our question states, for the following, sketch the graph of the equation, then determine if the equation is A, it's a function, meaning if it passes the vertical line test. B is if the inverse is a function. The test we used to determine that was the horizontal line test. And then part C, we're going to determine if the function is 1 to 1. And that means that the function passes the vertical line test and the horizontal line test. It must pass both tests in order for the function to be 1 to 1. All right, so let's go start with 21. Our question is r of x equals 2/5 x minus 9. You can type that into your calculator to see what the sketch is going to look like. But it is going to be a line going like that. Looking at your sketch, you can tell that it does pass the vertical line test because I could draw a vertical line through the function and it would only cross once. So yes, passes vertical line test. The inverse is a function if it passes the horizontal line test. If you draw horizontal lines through the function, it crosses once. So yes, it passes the horizontal line test. Because the graph passes the vertical and horizontal line test, it is 1 to 1. Because it passes both the vertical line test and the horizontal line test. On question 22, we're given another function, p of x equals 5 over x minus 6. You can type that into your calculator to see what the graph is going to look like. It's going to look like something like that, where you've got one part going down and one part curving up. That's kind of like what your graph is going to look like. Now that we know the sketch, we can answer our 3 questions. This graph does pass the vertical line test. So yes, it is a function because it passes the vertical line test. The inverse is also a function because it passes the horizontal line test. Right? I can draw horizontal lines through the graph and it crosses once. Yes, because it passes the horizontal line test. Because this function passes both tests, it is one-to-one. Because it passes the vertical line test and the horizontal line test. On question 23, we're given the function q of x equals 4x squared plus 2. When you type that into your calculator to see what the graph is going to look like, it looks something like this. Now that we know the sketch, let's go answer our 3 questions. On part A, the graph is a function because it passes the vertical line test. Yes, because it passes the vertical line test. Part B asks us if the inverse is a function, meaning you can test it using the horizontal line test. If I draw horizontal lines through this graph, it crosses more than once. So the inverse is not a function because the graph fails the horizontal line test because it crossed more than once through the horizontal line. Because it does not pass both tests, the function is not one-to-one because it fails the horizontal line test. That's a little review for you from section 1.3a, where we talked about functions, and 3.1, where we talked about one-to-one functions. Starting on questions 24 through 29, these you will not be allowed to use a graphing calculator on, because your job is to sketch what the graph looks like. On question 24, we're given the function f of x equals x plus 1 squared minus 3. First, we're going to state the transformations that occurred to make that function. The plus 1 on the inside tells us that we took the graph and moved 1 unit left. The minus 3 tells us to move the graph down 3 units. So those are the transformations that occurred. Now using that, I'm going to go sketch what this graph looks like. The fact that we know it's a quadratic, that is a U-shape. All that means is I'm going to take my U-shaped parent function and move it left 1 and down 3. 1, 2, 3. That's where the graph is going to come together at, and then just draw the U. Okay, there were no stretches, no shrinks here. This is just a sketch. And you can clearly see that I moved left 1 and down 3 units. That's what I'll be looking for on the test. On question 25, we're given the function f of x equals the square root of negative x plus 2. First, let's talk about the changes that occurred. The negative on the inside tells us to reflect the function over the y-axis. Because that negative is inside the function, that's why I'm reflecting it over the y-axis. And then the +2 tells us to move the graph up 2 units. Now let's draw our sketch. This is a square root function, which was the arc we talked about. First, I'm going to reflect over the y-axis, which will flip this over and move it up 2 units. And then draw it reflected over the y-axis. And that's a sketch of what your graph is going to look like. You can see that I reflected it, and you can also see that it shifted up 2 units. That's what I'll be looking for on the test. On question 26, our function is f of x equals negative absolute value x minus 3 plus 4 is on the outside. Let's talk about the changes that occurred. This is the absolute value function, which is just the V shape. The negative in the front tells us to reflect the graph over the x-axis. The minus 3 tells us to move the graph 3 units to the right. And the plus 4 moves the graph 4 units up. Now that we've got the changes, let's graph what this new function is going to look like. This is a V-shaped graph because it's an absolute value function. First, I'm going to reflect over the x-axis, which just moves the graph over the x-axis to point downwards. Right 3, so 1, 2, 3, and up 4. So from 0, 0, remember that's the point you start at. Move right 3 and up 4. And flip it on down, so that way it's reflected over the x-axis. You can see from that graph that I did reflect over the x-axis to make it go down, moved right 3, and then moved it up 4 units. On question 27, our function is f of x equals negative x plus 2 to the 3rd power. This is the cubic function, which looks like this vertical S. The negative out in front tells us to reflect the function over the x-axis. The plus 2 on the inside tells us to move the graph 2 units to the left. Now, using those 2 transformations, I can sketch what this function is going to look like. The x to the 3rd told us what the parent function looked like. I'm going to reflect the graph over the x-axis, which just flips it on over, and shift it from 0, 0, shift it to the left 2 units. Now I'm going to just sketch my graph with its reflection over the x-axis. That's what your function looks like. It's reflected, so it flipped, and it shifted 2 units to the left. On question 28, the function we're given is f of x equals 2x plus 1. The 2 in the front, because it's in front of the x, it tells us to vertically stretch the graph by a factor of 2. Because the 2 is bigger than 1, that's why we stretched it. This is going to make the graph narrow. The plus 1 tells us to move the graph up 1 unit. All right, now let's sketch. This is a linear function, which means it's going to be a line, because that's just x. And the plus 1 tells me to move the graph up 1 unit. Then just sketch your line. Okay, there's your linear function with a vertical stretch by 2 and up 1 unit. On the last question on this section, question 29, the function is f of x equals the cube root of x minus 1. First, let's talk about the transformations. The minus 1 on the inside tells us to move the graph 1 unit to the right. Because it's minus 1 We're shifting it 1 unit to the right. Now that we know the change, let's go ahead and graph it. This is the cube root function that looks like this for the parent graph. I'm going to shift it from 0, 0, go 1 unit to the right, and draw my graph. And that's what your sketch is going to look like, shifting the graph 1 unit to the right. If you struggled with questions 24 through 29, this did come from section 1.6, A, B, and C, where we talked about graphing transformations of parent functions. On question 30, this is the last question on your test review. We are asked to graph the following piecewise function, f of x equals x squared, where x is less than 0, and the negative absolute value of x, where x is greater than or equal to 0. Since you do not have a table on this one, I would recommend drawing a quick 6x3 table just so that you can kind of get a setup of what the graph's going to look like. In the first row, I'm going to label that x. The second row, I'm going to label that the equation that we're using. And then the last row, I'm going to put the ordered pair, the point, x comma y. Now we need to think about what x values we're going to plug into our piecewise function. This is where the graph is going to split at 0. So in the middle of my table, I'm going to put 0 and split the table where the graph is going to split at. X is less than 0 means I'm only going to choose numbers that are less than 0 for the first two spots, like -2 and -1. For the last two spots in my table, I'm going to choose numbers that are greater than 0, because that's what that x is greater than or equal to 0 means. So I'm going to use 1 and 2. That's the setup of our table, and again, that came directly from looking at the intervals for x. To complete the table, now I'm ready to just plug in the x values into each function. -2 is less than 0, so I'm going to plug -2 into the x squared function and simplify. -2 squared is 4, so -2 is what I plugged in, and 4 is what I got out. -1 is less than 0, so I'm going to plug it into the first function, x squared. Now to simplify, -1 squared is +1. So our ordered pair is -1 comma 1. The next value is 0. I'm going to plug that into the first function. 0 squared is 0. Because this is where x was less than 0, I'm going to use an open dot for that ordered pair. Since 0 is where the graph broke at, I'm also going to plug in 0 into this bottom function. Negative absolute value of 0 is just 0. Since this is where x was greater than or equal to 0, I'm going to use a closed dot for that ordered pair. Next value we're plugging in is 1. 1 is greater than or equal to 0. So I'm going to plug 1 into the first function, which makes -1. And same thing with 2. 2 is greater than 0. So I'm going to plug that into the second function, which gives us -2. Now that we've got the table completely filled out, we're ready to sketch what our graph is going to look like. Starting with the left side of our table, -2, 4 is right here on your graph. -1, 1 is right here on the graph. And 0, 0, that had an open dot. All of those points came from the first function, so I'm going to connect those dots together with an arrow going to the left, because that's where x is less than 0. The right side of the table came from the second function. Now I'm going to graph those. 0, 0 is a closed dot. And that's certainly fine that they overlapped there. 1, -1 is another ordered pair. And 2, -2 is another one. Those came from one function, the second function. So I'm going to connect them together. That is where x is greater than 0. So I'm going to draw an arrow to the right, showing that those values are greater than 0. That's the end of your test review. If you guys have any further questions, please feel free to email me or go back and look in the key that I posted online for your test review. Don't forget the chapter 1, part 2 test is Friday in class. So please email me if you guys have any questions before the test. Have a good day, Huskies.